So our speaker today, Abby Kessler, is a New Hampshire native and Massachusetts transplant, also a transplant here. She joined HomeWorks Energy in 2018. She started as a home energy assessor, performing assessments through the northern section of the state. Shortly after starting at HomeWorks, she received her Building Performance Institute, BPI, certification. She has since moved over to the marketing department and now manages channel partnerships. In her current role, she works closely with a diverse range of community, nonprofit, and businesses across the state who work together to raise awareness about the importance of residential energy efficiency. So I'll turn it over to Abby now. Thank you, Abby.
Yes, thank you so much. Yeah, thank you. Everybody for joining and for having me tonight. Really excited to go through this presentation with everybody tonight and share a little bit more about residential energy efficiency. So I'm just going to share my screen real quick and hopefully, I don't use Zoom very often. I use Teams usually, so I hope this is okay. Can everybody see my screen?
Yep, looks great.
Okay, perfect. And you can hear me okay? Great. Okay, awesome. Yeah, so like Kate said, my name is Abby and I live and work in Massachusetts. So I did start out as an energy assessor with a company called HomeWorks Energy and have since moved over to the marketing department. And this presentation tonight is really going to dive into like the Mass Save program and the importance of energy assessments. And then we'll go over some things at the end of the presentation that you can do today in your home to improve the efficiency of your home right after this presentation. So that's kind of like the flow of this. And then, there will be some time at the end of the presentation where we can do some question and answers. And if you could jot down, some questions or thoughts that you have during the presentation, and then we can bring them up at towards the end of the, presentation, that would be great. And so that's a little bit about it. So I'm just going to dive right in. So I'm going to start with a little bit of background about the Mass Save program. So, Mass Save has been around since the 1970s. So it's been around for a long time now. And it was started as a result of the energy crisis that was going on at the time. At this time, it was really when people started becoming aware about energy efficiency and that, fossil fuels were a finite resource and energy efficiency started becoming a topic that people, started to talk about and became interested in. So in the beginning of this program, each utility company operated their own energy efficiency programs. But it was a little bit disjointed because there's several utility companies in Massachusetts. And in 2008, the state legislature passed something called the Green Communities Act, which mandated that all energy efficiency programs come together under one umbrella that's now known as Mass Save, and it's identified by this logo that you see here on the right. So the program is funded by a small charge on customers' electric or gas bill. So that's why, you hear this term no cost energy assessment, because people are paying into the program every month on their utility bills. The program is also funded a little bit by this, some state money goes into it, and then also the utilities do it as well. So that's how the program is funded, but the majority of it is paid through this customer charge on those bills. And so that's a little bit more about the program. So during a standard energy assessment, there are really essentially three things that an assessor is going to do while they're in your house. So the first thing, and one of the most important things, is a health and safety check on the heating and cooling systems in your house. So these are combustible appliances. And one of the things that assessors are checking for is for high levels of carbon monoxide in your house, which can be dangerous. They're really checking to make sure that these combustible appliances are running safely and efficiently in your house. An energy assessment also consists of a thorough, insulation check to make sure that your home is properly insulated and running efficiently. And during a Mass Save energy assessment, you also will see, the installation of instant savings measures. So incandescent light bulbs are changed out with LED light bulbs. There are programmable thermostats that are installed in people's homes, and also some water saving devices as well. So all of these are no cost to the homeowner or renter the day of the assessment, and start helping people save money and energy immediately. And then at the very end of the assessment, there is a custom home report that is printed out and given to the homeowner or renter. And this shows the customer all of the things that can be done to make their home more energy efficient after the assessment is completed. So since the pandemic, MassSafe has implemented a virtual energy assessment option. So this minimizes the time that the energy assessor has to spend in the home. So you can schedule online or over the phone. And afterwards, homeowners will receive a confirmation email with a link that is included that homeowners can use to answer questions and take photos of their home prior to the assessment. So the virtual energy assessment is done over the phone or by video chat. And if the homeowner decides to go through with the insulation work, there would be a quick quality control walkthrough to make sure that everything spec'd out on the phone call is accurate. But basically, this virtual energy assessment option is available so that everybody can remain safe during the pandemic. Basically, an energy assessment is a comprehensive inspection or review of a home energy's performance. And we're really taking a whole home approach when we are looking at homes. So, for example, when we're looking for things like insulation, there are three main areas that we check when we're in the home. So we check the basement, the walls, the exterior walls, and the exterior walls, and the attic. So houses act a little bit like a chimney where cold air infiltrates in through the bottom of the house, and then you're paying to heat it, right? So warm air is, so that air infiltrates in through, it gets into your house through the bottom, and then it's going to heat up in your house, and then it's going to, warm air rises, and it escapes out through your attic. So any penetrations in the attic floor, warm air is going to escape out of those and eventually out through the top of your house. So, cold air is infiltrating, warming up, and escaping through the top of your house. So this being said, it is really important to insulate, the basement so you can minimize how much air is infiltrating into the bottom of your house. There is a ton of surface area on the exterior walls. So if you don't have insulated exterior walls, it's kind of like going out into the middle of winter, a freezing cold January day without a jacket on or a sweatshirt. It's kind of like going out in a t-shirt. And then also it is important to insulate an attic to make sure that there is, warm air isn't escaping out through the top of your house. So those are the three main places where, an energy assessor would be looking for to make sure that insulation is at the proper level. So in the basement, walls, and attic. And insulation was written into the building code in the 1980s. So houses built prior to 1980 often don't have proper insulation levels. So that's just something to keep in mind. But while we're looking at insulation, we also have to be aware of a lot of other things as well. So if we insulate the house, we're sealing up the air. So we need to be looking out for harmful gases that could be in the home as well, such as things like carbon monoxide or mold or something like that, because, carbon monoxide is going to have less chance to escape out of the house once the house is sealed up tighter. So we really need to be making sure that, everything is safe in the house before we seal it up a little bit tighter through insulation. So that's what we mean when we say we're taking a whole home approach. We're really looking at the home as a whole unit and not just in sections. I have mentioned this in previous slides, but one of the first things that we do for an energy assessment is we would be looking at the heating and cooling appliances, and we would be doing a safety check on each of these combustible appliances. But what does that really consist of? So it does sort of depend on what kind of system heating system you have in your house. Here in these pictures, we see an atmospherically vented system. So this system is venting into a chimney. And basically this energy assessor is looking for high levels of carbon monoxide in this on this hot water tank. And he would also look at it in the boiler as well. He would also be making sure that flue gases are moving up and out of the flue properly and into the chimney. There is something that can happen called backdrafting, where these flue gases are coming back into the living space and can be harmful to our health. So we're also making sure that everything is venting out of the house properly. So yeah, it does depend a little bit on what kind of system you have, but an energy assessor would always be looking at carbon monoxide levels, and then also that the flue gases are escaping out of the house, so that yeah, we just want to make sure that they're escaping out of the house properly. So that's kind of what we're looking for when we're doing a house, heating and cooling safety check. So after the combustion safety test, this is when the assessor does look for any opportunities for insulating the house a little bit better to make it run more efficiently. So here are some of the treatments that Mass Save pays for or incentivizes. And yeah, in the bottom left corner, this shows a picture of a well-insulated rim joist. So a rim joist is in the basement of an unfinished basement. It's where the foundation meets the ceiling in a home. So connection points in homes are naturally very leaky, which is why it's important to target this area and insulate it. So in a lot of houses, you will see that the whole ceiling is insulated, but actually the newest approach is that actually just around the perimeter of the basement is the area that needs to be targeted. Like I said at the beginning of this presentation, the house sort of operates like a chimney. So cold air is infiltrating in through the bottom of your house. So this is where cold air is coming into your house, is at the bottom here in the basement. So if you insulate the rim joist, you're minimizing how much air can infiltrate in through your home, through the basement. So this top left picture is of a really well insulated attic. So underneath all of this insulation that you see here in this picture, there is spray foam, which is used to seal the penetrations on the attic floor. So this is places where ductwork is cut or electrical penetrations have been cut. Something called a top plate, which is where your walls meet your ceiling, and it's another connection point, and connection points are naturally leaky in people's homes. And like access area, so like a pull down staircase or a walk up staircase, those are all places where warm air is rising from your living space and getting up into your attic. And you really want to keep that in your living space because you're paying to keep that air, so you want to keep it where you are, in the finished areas of your home. So all of those penetrations are sealed with something called air sealing or a spray foam. And then after all of those penetrations are sealed off, we would add 14 inches of insulation to the attic floor, which would create a really nice blanket over the top of your attic, so that warm air can't rise up and out of your home. So that's kind of the approach that Mass Save takes when they're looking at an attic. And on the far right, you'll see this is a picture of, I'm not sure if you guys can see that or not, but yeah, this is a picture of a wall. And basically, if your walls aren't insulated, like I said before, it's kind of like walking out into the middle of a cold January day without a jacket on or a sweater on, and we would never really do that. So yeah, that's kind of like this. What you're doing to your walls if you don't have insulated walls. And one of the ways that we can retrofit insulation into walls is by doing something called blown-in insulation. So this comes through a hose, and they just pump this in through a hose at a high speed, and it dense packs into the cavity of the wall and creates kind of like a full, it's almost like a bat. But you don't need to open up the whole wall by taking the drywall down or anything. You would just do this from the exterior of the house through a small hole that they would cut into the wall and then seal off at the end of the project. So this is one way to retrofit insulation in walls. And then in the middle picture here, this is usually, these spaces are usually in Cape houses. They're just kind of extra spaces. They're usually triangular, and we see them often in Cape or Victorian houses. And these are also usually unfinished attic spaces that need to be sealed off. Using in this circumstance, they use this fiberglass batting underneath, and then something called a polyiso board, which is spray foam that comes in a can, but it's actually just in board form. So that's what this polyiso board is. So anyway, this is just all to show you that there's a lot of different types of insulation that we use in different parts of the house, or to target different parts of the house. So yeah, this is air sealing. So air sealing comes in a can, and we spray this on in different parts of the house. In this picture here, this is a huge, opening, huge hole going up into your attic. This is a pull down staircase, and this is a really leaky place in your house. There's a lot of warm air, or warm air in the wintertime that is rising up into your attic and escaping into your attic through this huge gaping hole that many people have. So what we're going to do here is we build this big box called the T-dome, which is made out of that polyiso board, and we would put that over that gaping hole to minimize how much warm air is escaping out of your house. And then also, in an attic space, this is they spray foamed all of the top plate leaky connection points so that warm air couldn't escape up through those small cracks and crevices in your attic floor. So it might not seem like a lot of area that they're spray foaming, but actually if you do the math and add up all of this, all the places where they're spray foaming, it actually amounts to like a half a window being open in your house all winter long. So if you add up all the cracks and crevices in your attic floor, it amounts to, half a window being open all winter long. And you would never leave a window open during the winter time. So that's if your attic isn't spray foamed, that's essentially what's happening there. And the basement, this is the rim joist that I was talking about. This is the perimeter of the basement. And they basically sealed this off with spray foam and then that polyiso board as well to minimize air infiltration, cold air infiltration into the home. So those are some of the ways that we use air sealing. Air sealing is actually 100% covered through the Mass Save program, so homeowners or renters don't pay anything for that. And then, this is actually what they do after they, spray foam the attic floor. They actually add 14 inches of insulation, and this is a blown-in insulation. This is pumped in through a hose as well, so it's run through the house and then pumped in through a hose. This blown-in cellulose insulation is made up of shredded up newspaper, actually, that's dipped in a flame retardant and then sprayed in through a hose. And it's actually a really good insulator. It's also the most carbon it's the most carbon neutral or carbon effective way to insulate a home. So this fiberglass batting has more of a carbon footprint than this blown-in insulation. So that's just that's interesting about blown-in insulation. It's also really easy to apply because you just kind of spray it over the floor of the attic, so it doesn't take very long to install. Like I mentioned before, we're really looking at a whole home approach. So when we are insulating an attic, we are looking for proper ventilation while we're doing this as well. And there is a really specific calculation that needs to be taken into consideration when you're adding insulation to your attic. Basically, you want to make sure that you still have air that is flowing through your house. You want to make sure that your house is still breathing, because it can create mold. If there's really stagnant air in the attic, it can create mold issues, which is a health hazard. So we want to make sure that there's the proper amount of ventilation. Here, we can get proper amount of ventilation through a number of different ways. One of them is a ridge vent, and then we also can do soffit vents, and then we can also apply some other vents as well in the roof of the ceiling. So it's just really important that your house is breathing, because we don't want to, we want to minimize we want to minimize mold creation during that. And there's also things like bathroom fans that we often see that are just kind of, they're venting up through the ceiling, but they're just kind of dumping all of the warm, moist air is dumping into the attic. And those should really be vented through the ceiling, because that can create a moisture issue and then mold in the attic as well. So we just want to make sure that there's not excess moisture in the attic. So these are some health and safety issues that we do run into pretty frequently while we're doing energy assessments. In the top left corner here, you will see knob and tube wiring. This is the oldest form of wiring. It's an original form of wiring. It's wire that's wrapped in cloth. Basically, this is a fire hazard, because if you can think about electricity and cloth, if there's a spark that happens, it could create, it could catch onto the cloth and fire could start. So if we were to do any work, we would just want to make sure that basically, the wires are disconnected before any, insulation work happens, because in old houses, this can be a really big fire hazard. In this middle picture here, you do see mold that's created on the bays of the attic ceiling. This is black mold, and it can be harmful to your health. So this is an example of a moisture issue or a ventilation issue that wasn't addressed properly. And we see that in a lot of houses. So that is something to keep in mind as well. And this picture over here on the right-hand side, this is a picture of vermiculite. And vermiculite was an insulation, a type of insulation that was used back in the 60s or 70s. I'm not quite sure what decade, but it was really popular. It came in bags and people were just dumping it into their attic as an insulator. And it is actually a really effective way to insulate your house, but it all came from a mine in Montana that had an asbestos seam that was running through it. And so that when they blasted all of that vermiculite, there's a chance that, some asbestos got into that insulation. And as we know, as many people probably know already, asbestos can become airborne, and then it can cause lung cancer or mesothelioma. So yeah, this is also a health hazard that we're looking for when we're in attics. And we often see this in walls and in attics. And then on the bottom left here, this is an example of an ice dam. Basically, this house is losing a lot of heat through their attic. It's melting the snow on the top of the roof, and then it's creating these huge icicles. So we can just see from this picture that, this house is losing a lot of heat through the top floor of their house, and probably isn't very well insulated. So yeah, there are, during part of the assessment, there are some instant savings measures that they'll give to you at no cost for that will start saving money immediately in the house. Basically, this picture right here is of a water faucet aerator. You can pick these up at any store. They're super cheap. But this is basically the thought here is that it reduces water. This is on a kitchen sink, but you can also buy them for your bathroom sink as well. And basically the thought is, like, if you know how in the summer you have a hose and you can put your thumb over the hose and you're reducing the surface area of that hose, but the pressure comes out, the water is coming out a little bit faster. So these faucet aerators operate under the same sort of principle, where it shrinks the amount of surface space, but the water pressure comes out the same, or if not harder on those. So you're using less water, but you get the same amount of pressure. And same with shower heads. We actually do install these shower heads as well, these handheld shower heads. And the same concept applies, is that it reduces the surface area, but it's the same amount of pressure, or more pressure even, that you're getting with that, that shower head that's using a lot less water. It's usually reducing your water usage by 1.5 gallons per minute. So it does actually add up over the long term. And then this is a programmable thermostat. So these are a little bit more efficient than like Honeywell round thermostats. This you can set a schedule into. So when you wake up, when you leave the house, when you come home, and when you go to sleep, it would automatically adjust the temperature depending on when you're home and when you're not home. So you can set a schedule in there to adjust the temperature automatically. And all of this stuff is, no cost the day of the assessment, but you can also go out to any hardware store or, Lowe's, Home Depot, anything like that, and get any of these products that will start saving you money immediately in your home at a pretty, cheap price. And yeah, also MassSave provides, no cost LED light bulbs. So any incandescent bulbs you have, they would change those over to LED bulbs. And then these are smart power strips, which cut back on something called phantom power draws, which means if you leave, your phone charger plugged in or your computer charger plugged in, but it's not actually plugged into your phone or your computer, and they're just plugged into the wall, that is still drawing power from the outlet, even though it's not plugged in. So these power strips minimize those phantom power draws. That's another way that you can quickly save energy in your house. At the very end of the assessment, I mentioned this before, but the energy assessor would go out to their car and they would type a bunch of information into their computer, and it would spit out a lot of different pieces of paper that they would then share with the homeowner. And one of those pieces of paper is a report that shows all of the instant savings measures that were installed the day of the assessment. So in this particular house, all of these things, were installed. There was a lot of light bulbs, a faucet aerator, a thermostat that was installed, and it was a total of $494.75. So that was the value of all of the things that were installed the day of the assessment. The homeowner didn't pay anything, and then they have an estimated annual energy savings of $202.90. So that's like how much you would save over the course of a year because of all of the energy, the light bulbs and the thermostats and stuff that were installed the day of the assessment. So the homeowner doesn't pay anything for any of those. And then this is some insulation. This is another piece of paper that a homeowner or renter would receive in the packet at the very end of the assessment. And this is, this homeowner needed some more insulation in their, mainly in their attic and in their walls, in order to bring it up to current building code. And the estimated cost for that project is $2,839. But Mass Save pays for $2,129 of that, and the customer would cover this cost. And this is the estimated annual energy savings of $507. So this is the return on investment of that project. The estimated payback would be about 1.5 years on that insulation. So insulation has a really good return on investment. If you install something like solar panels, that's going to take sometimes 15 or 20 years to pay back, but insulation is usually 1 year to 1.5 years. So it's just something to keep in mind. One of the things, just during the installation of insulation, crews are taking, the utmost precautions these days when they're installing those measures. They're wearing full hazmat suits. They're wearing, N95 masks and gloves to make sure that everybody is safe during these during these times. So I did just want to touch on some HVAC, some heating and cooling things as well, some high efficient heating and cooling solutions. One of the most efficient things on the market right now are these things called heat pumps or ductless mini splits. So these are really efficient heating and cooling alternatives. These systems do both heating and cooling. So you don't need ductwork in order to distribute the heat or air conditioning through the house. So if you wanted something like central air conditioning, but you didn't want to install ductwork, these ductless mini splits are a great alternative. Installing ductwork is super invasive and it can be very expensive if you're doing a retrofit. So ductless mini splits can be installed in certain rooms, and one of the fans on the exterior of the house can support 3 of these heads in different different rooms in your house. So one fan on the outside can support 3 heads on the inside. So this is a great, alternative for for running, for I guess, central air conditioning. So people like to install ductless mini splits in 2 instances in particular. If you heat your home with electricity, this can be super, super expensive. If anybody on this call heats with electricity, they know that the bill can be very expensive in the wintertime. So ductless mini splits are a really great alternative to heating your house with electricity. And then also, a lot of people install ductless mini splits for, if you have window air conditioning units. These are a great alternative to window air conditioning units. Window units are very heavy and can be really hard to install in the summertime, especially if you're older or elderly. These, the window units can be kind of physically restrictive. So ductless mini splits are a great alternative to that. And as you can see in this chart, ductless mini splits range from 200 to 400% more efficient depending on the outdoor temperature compared to other heating and cooling alternatives. So their efficiency does depend a little bit on the outdoor temperature. So they're most efficient in the spring and the fall. So when the temperature difference isn't quite so drastic, those are when these units are running most efficiently. If you have a really freezing cold day, like it's the middle of January or something, and it's 0 degrees, as we experience here in the Northeast kind of often, these heat pumps or ductless mini splits aren't very efficient at heating a home because they're working way harder to pull warm air from the outside temperature and put it into the house, So yeah, these systems are most efficient during, sort of more mild days when you just want the temperature variation to be a little bit, you want it to be, your living space to be a little bit warmer than it is or cooler than it is outside. So that's when these things run most efficiently. Right, so all of these upgrades to a home or rental property can be financed on something called the heat loan, which is a 0% interest rate loan that Mass Save covers for 7 years. So yeah, basically this loan, you can use it to finance heating or cooling systems with ductless mini splits that we were talking about, new air conditioning systems, single pane window replacement. So if you're moving from a single pane to a double pane window, you can finance that upgrade out using the heat loan. Any installation recommendations, the remaining copays on those, even though they're often nominal, they're pretty small because Mass Save covers most installation costs. That would be covered through the heat loan as well if you wanted to finance that out. And any health and safety issues, we were talking about vermiculite earlier, mold, any of that remediation can also be financed using this heat loan. And that they're basically just trying to get you to the point where you do the upgrades on your house. They want to make it enticing to do these energy efficiency upgrades on your house. So that's why this heat loan is available, or the 0% financing loan is available. Yeah, so I just wanted to jump into about ways that you can start saving energy without like having an energy assessment. You don't have to necessarily sign up for an energy assessment to start saving energy today. So one of the things, I have a couple of different ways that you can, couple different tips and tricks that you can do today in order to start saving money in your, rental property or your own home. So one of the first things that I did when I moved into my apartment was I went downstairs and I found my hot water heater, and I actually reduced the temperature of my hot water tank from, it was actually, mine has a small dial at the bottom, and it was on very hot, and actually the water was like scorching hot. So if you were in the kitchen and you put the faucet on hot, you would burn your hand. So I went downstairs and, I turned it down to like warm. So it was really reducing the hot water heater from like about 140 degrees to about 120 degrees. And there's usually just a dial on the bottom of your hot water tank that you can usually minimize in order to make that change. And that is a really good way that you can like start saving energy and money and not really notice that much of a difference. You're not like really compromising anything, right? So yeah, another thing that you can do is keep your fridge. If you have like an extra fridge in your house, a lot of people have freezers or extra refrigerators in their basement. If you keep these, fully stocked, it's actually more efficient than keeping them like half empty or empty. So that's another little trick that you can use in order to, save a little bit of energy on some of those extra appliances that you might have in your house. Another one is wash your clothes in cold water whenever possible. That's a really great way to start saving energy as well. You can run your dishwasher with a full load, so don't run it on half empty or half full. Release, pack it full, and let it air dry when it's finished. And then you can unplug your phone chargers when they're not in use. So this is cutting back on something called phantom power draws that we were talking about a little bit before, when something is plugged into the outlet, but your phone isn't actually plugged into it, it's still drawing power. So really just unplug it from the power source and you're finished with it. And that's another way that you can start saving energy as well. And Mass Save has like a ton of tips. I just want to show you guys that, if you go to this website, there's just loads of ways that, DIY things that you can do to your house in order to make it more efficient. And I would really, just recommend reading this. And if you had any questions about, your dishwasher, your refrigerator, your freezer, cooking, there's all sorts of different tips and tricks on ways you can save water and energy in your home that you can do yourself. So if you're interested in this topic, this is a lot of great reading and a great resource to, finding more ways to, save energy and money. So I wanted to show you that. And then, there's a lot of different reasons why, people should be interested in this topic. one of the, I guess, unifying things is that we can really save a lot of money by cutting down on our energy usage. If we're using, less electricity or less gas in our house, ultimately in the long run, we stand to save hundreds, if not thousands of dollars. So it's a really, saving energy is really like good for your wallet. You can save a lot of money by doing it. You can also increase the comfort of your house. So in the wintertime, you wouldn't be getting as many cold drafts into your house. And in the summertime, you also, would be keeping your home cooler if you had, a really efficient house. So it's really more comfortable to have an efficient house as well, both in the wintertime and in the summertime, because it's keeping your house, warmer in the winter and cooler in the summer. And then, obviously being green, this is one that I'm really motivated for, or because of, this is why I got into the industry in the first place. I'm really interested in the environment. I'm interested in climate change. I think it's a huge issue. I think preservation is a big issue. I think, this is one way that we can conserve energy, not come up with alternative energies, but really conserve it right where we are today. This is basically the whole reason that I got into this industry in the first place, is to become, a little bit more green and learn more about the industry. And then, we talked about a lot of health and safety barriers, the mold, the vermiculite, the knob and tube, all of those, or the carbon monoxide as well. All of those things are, present in a lot of homes in Massachusetts in particular. Massachusetts has one of the oldest housing fleets in the entire nation. And these health and safety barriers are in a lot of houses out there. So it's just good to know what's in your house and make sure that, it is healthy and a safe place to be for you and your family. And then another reason to do all this work and make your house more energy efficient is for preservation. Things like tuning up your heating and cooling system on a yearly or every other year basis can help preserve the lifetime of the HVAC system, and eventually, you wouldn't have to replace it. You can extend the life of it and wouldn't have to replace it maybe as quickly as you might have had to in the first place. So there is a preservation aspect to keeping your house energy efficient as well. And this kind of concludes my presentation. If you have any questions at all, happy to take them now, or you can reach out to me. I put my email address in here. I also put my cell phone number, so feel free to reach out via email or phone if you think of anything after the fact. If you have a question that you want answered or anything like that, please don't hesitate to reach out. I'd be happy to try to answer your questions. So I don't know if anybody has any questions like immediately or right now. I'd be happy to try to answer those. And then, like I said, if you have anything, if you think of anything after the fact, please don't hesitate to reach out. So thank you so much for having me today. I really appreciate the time.
Thank you so much, Abby. So if anyone has any questions, please feel free to unmute and ask or type in the chat, and we can get to your question. I have a quick question. Why is a fully stocked fridge more energy efficient than a half empty fridge? I was wondering that.
Yeah, for sure. Basically, I think you can probably read up all about it in this. I think it has it here, the exact reason. But my understanding of it is that if your refrigerator is fully stocked, then everything in the refrigerator or the freezer would be keeping itself cool. So it wouldn't be working as hard to everything around it would be keeping it cool. It's kind of like an insulator.
Oh, interesting.
Yeah. Mm-hmm. Yeah. I think, this probably has a full description of it, but just because everything around it, it's kind of like insulating itself by being around other things that are cool.
I feel like there's so much more physics in energy efficiency than I ever thought about.
Yeah, it's definitely like building science. There's a lot of science that goes into, insulating your home and energy efficiency in general. There's a lot of science and physics that goes into it. It's super interesting to dive into the science aspect of it.
Thank you. Any questions from our audience? Okay. Shannon, in terms of next steps, so I posted Abby's contact information and the link to the Homeworks Energy in the chat. Is there anything else we need to do?
No, that's it. Like Abby and Kate said, if you have any questions, feel free to reach directly out to Abby since she provided us with her email. And then other than that, just thank you, Abby, for joining us tonight.
Thank you.
Yes, of course. Thank you so much for having me. I really appreciate it.
And thank you everyone for joining us tonight. Have a great night.
Have a good night. Thank you.
Thank you.
Thank you.